Hello, this is Yannis from Any Repair. Today we will go through a notebook repair, a notebook which model is elitebook 840G7 that came to our lab partially working, sometimes turned on, sometimes didn't turn on. Had an issue when didn't turn on with the beeping mode. It was 3 beeps long too short. Let's go and see what we will do with that. That's the board on our desk. We have, of course, disassembled board, and now we're plugging our Type-C charger. We will try to power it on, and hear the result of the beeping. I have connected the speakers for you to hear the problem. I am struggling to align my broken Type-C port in order for you to see the amps that the notebook is receiving. And now I will turn on the notebook with my multimeter in order for you to hear the result of the beeping. So, this board, its history is that was water damaged. Previous technician already tried to fix the problem and resolder the joints of the pin and the pads on the memory. You can see, we will see together the corrosion that was removed and the work that has been done on the pads and the pins. You can see there are some naked without solder pads, and there are some pins that have been resoldered. I will remove the memory to see the current DIMM, the DIMM 1 slot, that some soldering job is done correctly. This is not bad. We will test the pins to see if we have continuity. And here we are with our multimeter in beeping mode. We will test the lines from the pad to the pin. This is okay, not with beeping mode, as you can see with the ohm meter, which is more difficult. This is okay. This is okay. This is okay. This is okay. These two. These two. This is okay too. This is okay too, and this is okay. Everything seems to be okay. The soldering job from the other guy was good, but couldn't fix the problem. Now we have to check. We will power on again the board, and we will check for voltages. We will connect the RAM stick on the first DIMM slot. We will plug our charger. We will power on notebook with our beeping multimeter mode. Now we will check for voltages. We have voltages on the CPU, VSS, core VSS. Maybe this is the 3.3 volts. This is 5 volts. The previous was maybe the system agent. This is no, this is not. This is 1.2 for the RAM. This is 0.9, which is good. This coil has not any voltage. Maybe it is the VCC GT, which is not active, but the computer is not turning on. It's beeping, but we are having noise cancellation and you cannot hear it. Okay, and here we have a coil which is having 0.45 volts, which is strange. Let's see this little tiny coil which is having a regulator beside. You can see that it is having 0.45 volts. This is the regulator that controls the coil. And now we must check and see what this coil is standing for. So we need our board view. Here's the board view. We are around here. This is the regulator. This is the coil, the L6400. This is the pin that is controlling this coil. This is the enable, and this is the vein. Okay, the vein and the enable. We must check these two pins, the first and the fourth. Let's go now. We will power on the unit. We will turn it on and check for voltages. First the vein, and after that we will check the enable. Here is the vein, which is present, and there is the enable, which is having a voltage, but I don't think that 1.1 or 1.2 is an enable signal. But we will find out. Maybe it is the chip. Maybe it is the water that have corroded something. This coil stands for the 2.5 volts supply for the memory. That's why the HP notebook is beeping and complains about the memory that is not working. Of course it is not working without having this 2.5 volts, and we can see that the enable signal is coming from this area. Here we are having 3.3 volts, and there we are having the enable signal. So let's go and see that area and determine what's the problem. Here we are. Now we can see the upper resistor. The upper resistor is controlling the enable signal. It is pull up for 3.3 volts. Let's go and see if we are having this 0.3 volts, 3.3 volts. I'm trying to adjust my view better. And now we can see that we are not having anything. Let me put my probes in a multimeter in continuity mode. I'm trying to figure out what's the problem, but I can assume that this is water damage there in the pad. I will adjust the light in order for you to see better the gap between the resistor and the pad. You can see it now. You can see it now. We will add some flux and try to repair this broken connection between the resistor and the pad. So we'll add some flux and try to rewire the pin of the resistor to the pad that it is broken. We will need to scratch and reveal the copper. We will need to scrape off the mask and reveal the copper for the flux and the solder to get on the pad, to stick on the pad and hold down the wire properly. And now we will try to solder the wire. Okay, I'm trying to solder the wire. We will go in a quick mode. I'm struggling to solder the wire, and after I have soldered the wire on the pad, I will try to connect it, solder it on the resistor, but I'm sure that the pin of the resistor is broken, corroded by the water and cannot absorb the solder properly. So I will remove it and place another one. I'm struggling there to solder the wire, but it is not soldering properly. And after that, after the cleaning and the inspection, we will determine that the resistor must be replaced by pressing this resistor. I will damage the pad that is connected. The pad was good and the resistor pin was good, the other one. But I will fix it, there's no problem. I will find a good resistor, a 10K resistor that must feed the enable signal from the 3.3 rail. We have already scraped the pad. We will add some flux. We will add some solder. Here's the resistor, a new one, a good one. We will solder the first pin of the resistor on the left, on the right, and after that we will run a wire to connect to the other pad that we have ripped. I will feed the solder to the resistor to make things easier for soldering the wire. And now with a piece of wire, I will make the jumper. I will replace the pad that I was ripped. I like using enameled wire. Sometimes the job is harder to do, but enameled wire is no risk for me, so I like using it. Now the trace has been restored, and I think we're good. We will clean up a little. We'll use our scientific toothbrush. And I think we're good. Now we will turn the board upside down. After we check for the 10K, which are good, we will go to the overhead camera, connect our charger, power on the notebook, the board, and see if we are having the 2.5 volts that we ought to have in order for the notebook, for the board to work properly, and the notebook not to beep and asks for memory. Okay. We will use our multimeter again to power on the board. Okay, it is powered on. Let's go and measure the voltage on the coil. The other side of the coil is better. It's 2.5, you saw it. It is good. The notebook is on. It's not beeping. You can see that I am having the speaker on board. It is not beeping. And I think we're good. Now we will assemble the board on the chassis in order to check if we are having display or not. Unplugging the charger. It's getting some power. I will press the power button. And we are having display. We are good. The notebook will power on. We will load Windows 11. And I think we're good. This notebook is fixed. You saw the enable missing of the 2.5 mem voltage. We are good to go. That was the repair as you saw. If you liked this video, consider like, subscribe and share. Thanks for watching. See you in another repair. Bye.